Hey guys, how are you doing? Today we are going to solve longest substring without repeating characters problem. Let's understand the problem statement. Given a string, we have to find the length of the longest substring without repeating characters. The substring can be a single character or the sub-array of that list, right? So which does not contain any duplicates. So we have to find the maximum length, right? Maximum length, and then we have to return that. So let's see how do we solve this problem. First, we are going to see how this problem can be solved by brute force method. That is, we are going to generate all the possible substrings, and then we have to check. So to generate all the substrings, you have to maintain one start index, and for each start index, we have to have an end index, and we can from that start index to end index, we have to just generate one substring, right? You have to iterate each and every character from that start index to end index. So that will also be, in the worst case, that iteration becomes n, and the end index iteration becomes n in the worst case, and also this I becomes n. So overall, the complexity is n cubed, which is very slow. And the space complexity, if you see, in the worst case scenario, will be, having the whole string in the memory or the whole char set. Okay, so which means the ASCII characters, right? The whole char set in the memory. So we're going to take the minimum of it. So at any scenario, we won't exceed the char set length, right? So this is a space complexity. And the next method, what you're going to see in this video is the sliding window method using HashSet, which runs in, they go off n time complexity, that's linear time complexity, and the space is just the same because we're gonna store all the characters in a substring, okay, in a set. So the space is same as the brute force, and we're going to optimize the sliding window method, to run in the linear time. Okay, so for this method, we are going to maintain a sliding window. That is, we are going to maintain a start index and end index, and we are going to add character by character to the set. If we face a duplicate here, we're going to remove one by one from the beginning of that sliding window, beginning of the set. So there should be two indices. One is the starting index and the end index, and whenever we face a duplicate here, we're going to remove one by one from the beginning, from the start index, and also from the set. Okay, so the size of the set will be the maximum. So what is the size on the sliding window is going to be the maximum substring we will find on the go. Okay, so that is one approach, and what is the difference between these two approaches? See, if you see the runtime is, you know, uh, twice the n, because for every end index, we have one start index. For every end index, we will be iterating all the characters. And if we face a duplicate here, we're going to remove character one by one here, okay, till we reach the next element of the duplicate. So in this case, we'll be iterating each character twice, right? So that is the actual runtime in this method. In this method, we will just avoid, iterating and removing one by one from the set. So what we are going to do is, so we'll maintain the key as a character and the value as the next element's index, so that if we face a duplicate, we can directly jump to this index. Okay, so in that case, we will avoid iterating twice. Okay, so if you see that this is a sliding window we are going to maintain, which is the start index, we'll be pointing to a character like this, and then we are going to add character by character by incrementing just j. And if we face a duplicate like this, okay, so the set already contains that, right? So we are going to remove the characters from the sliding window, from the beginning of the sliding window, one by one, and we'll be reaching to till this character. Like this is our new sliding window for this case. And then we will continue the end index to add new characters to that set. Okay, so this is one approach. And for method three, what we are going to do is same. Instead of hash set, instead of storing the key only, we're going to store key and as well as the value. The value will be associated with the index. Okay. So the value is actually an index of the next element. So the value we store here is the index of the next element, because whenever we face duplicate, okay, so J is actually pointing to the duplicate character here. The hash set is already containing that. What we are going to do is just we are going to directly set I equal to the next element's index. So in this video, we are going to code all these three methods. Let's see how we do this. Okay, I'll define three methods here. One is the brute force, and then the sliding window method, and the optimized sliding window method. Okay, so let's say I'll define a function called method1, which accepts a string, and function method2, which accepts a string, and function method3, which also accepts a string. And then for the method one, this is the brute force method, right? So, I'm going to return maximum. So return maximum, and we're going to have three loops here. So for let I equal to 0, I is less than s dot length, I plus plus, and then let j equal to, we have to start from I. Uh, or I itself, because we can take the current index as one substring, right? So current character. So j is less than length and j plus plus, and for each start and end character here, for each start and end index here. So what we are going to do is, or let's have a set here, set, and for k, let k equal to start index, and k can go till the end index, k plus plus. Okay, there are three loops right here, and if the set does not have the character already, then what you're going to do is set dot add and update the maximum, math dot max mx set dot size. Okay, if it is already having the character whatever we are counting, then just come out of this loop. Okay, because we are not going to count anymore, because uh, whatever the character in the substring uh, will be having a duplicate, so we are not going to continue this loop. So we are going to move ahead and continue the next substring. Okay, so by this, let's run this. Maybe return method one of string. So run this code. So it works, but it will take a huge time. Maybe we can submit this and check. Yeah, it is taking huge time, right? So because the brute force approach, for each and every start index, it's going to be, exceed the time limit. So let's see how method two works here. Uh, so I'm going to maintain two index, right? Let I equal to 0. Before that, I'm going to have max equal to 0. I'm going to return that. So let I equal to 0, j. So j is also start with the first character, and we are going to have a set. Okay, so if the start index is less than the length and end index less than the length, then what we are going to do is if set has if set has the character of j, what we are going to do is we're going to remove from the beginning, right? So set dot remove or delete, sorry, delete s of I. From the start index, we have to just remove from start index. right? All the characters from the start index, and we are going to move ahead. If it is not containing, then we are going to push that. Add s of j, and we're going to update that max, right? ms so max mx equal to math dot max mx, and the end index minus the start index plus 1. So this is a length we'll be getting, all right? And also we're going to increment j. Okay, so see, if you see that if the set already contains a duplicate, we're going to remove, and this will be continuing. So if you see that only I will be continuing in this case, so not j. So j will be staying in that end index, right? That's where we are going to iterate twice a character, right? In the worst case, this loop will run in twice of n. Okay, so let's see how it. Okay, let's test this. Method 2. Okay, maybe let's submit this. Yeah, it works. Okay, and let's see the method 2. So this is taking some 80 milliseconds, right? So let's see the other method, because the worst case could be, O of n. It's just running twice. So it's still okay, right? For this method, we can just reduce that as well. So no need to, remove, or no need to iterate till it reaches the particular proper index. So we don't need to iterate it. So we can just directly jump to that index. So let's see how do we implement that. So let mx equal to 0, and I'm going to return the same mx, and I'm going to have a hash map, right? Let map equal to new map, and let I the start index equal to 0, and j will be 0, while j is less than s dot length. Okay, we are not going to check the start index end. Okay, because we know that it won't exceed j, right? So if the map is already having that character, okay, so if the map has the character already, so we are going to take that particular value and set it to that index, right? So we have to take the index and set it to I. So map.get and s of j. Okay, there could be chances that this entry index could be less than I. Okay, because we bypassed that entry, and then we went ahead, and then we faced the older duplicate. Okay, we faced the duplicate character, which is already old, which is already passed from the string. Okay, so in that case, we have to make sure that we are already moving ahead. Okay, so if we face a character which is already, bypassed by the window, this map entry will return the older index, right? So the current starting index must not go back. So we have to make sure, okay, take the maximum among that, because if the map contains, so either we have to remove it from the map, or we can just make sure that we are moving ahead, like whatever I and the duplicate, whatever we are facing, must be greater than I, right? So if it is greater than I, we can just skip this starting index and directly jump to that index, which is after the duplicate, right? We have to take the maximum of current starting index, either this can be maximum or the duplicates, which is falling further in the map, right? So if it is falling, behind the I, we are not going to take that index. We are not going to take that. So rather, we'll keep I itself. Okay. So after changing I, maybe we can just add the current index to the map. So map.add s of j and j plus 1, because the next index we're going to jump, right? So the current map entry must have the next item's index as well. And what we're going to do here is we're going to update the max, max.max and max, and the end index minus the start index plus 1 and increment to j. Okay, so yes, all right. Okay, let's test this method 3. I hope it's clear because this could be a little tricky. Let's test this. Add is not okay. Set. Sorry. Okay, maybe we can just submit this. Cool. It is actually, taking more time than this. Maybe we can just rerun that, see how it works. Again, some problem with the environment. Okay, but still, it is actually optimized. There is no much difference. Okay, in terms of the execution. But still we have some little optimization. We are just iterating only once. Here we are just iterating, sorry. Here just we are iterating twice. Here just one. Okay. Yeah. So hope you enjoyed this video and please comment if you have anything. And thanks for watching.